The moon's attraction is stronger on Earth's oceans closer to the moon and weaker on the oceans farther from the moon. This is because the gravitational force is weaker with increased distance. The ocean tides are caused by differences in the gravitational pull of the moon on opposite sides of Earth. This difference in poles across Earth slightly elongates it. The oceans bulge out about 1 meter on average on opposite sides of Earth. Because Earth spins once per day, a fixed point on Earth passes beneath both of these bulges each day, producing 2 sets of ocean tides per day, 2 high tides and 2 low tides. The 2 tidal bulges remain relatively fixed with respect to the moon while Earth spins daily beneath them. The sun also contributes to ocean tides, about half as much as the moon. Its pull on Earth is 180 times greater than the moon's pull on Earth, so why aren't solar tides 180 times greater than lunar tides? The difference in gravitational pulls by the sun on opposite sides of the Earth is very small because the sun is so much farther away from the Earth than the moon. A spring tide is a high or low tide that occurs when the sun, Earth, and moon are all lined up. The tides due to the sun and the moon coincide, making the high tides higher than average and the low tides lower than average. Spring tides occur at the times of a new or full moon. A neap tide occurs when the moon is halfway between a new moon and a full moon, in either direction. The poles of the moon and the sun are perpendicular to each other. The solar and lunar tides don't overlap, so the high tides are not as high and the low tides are not as low. Because much of the Earth's interior is deformable, we have Earth tides, though they're less pronounced than ocean tides. Twice each day, the solid surface of Earth rises and falls as much as 1/4 meter. There are also atmospheric tides which affect the intensity of cosmic rays that reach Earth's surface. The tilt of Earth's axis, interfering land masses, friction with the ocean bottom, and other factors complicate tidal motions. Earth's tilt causes the 2 daily high tides to be unequal. Two main processes go on continuously in stars like our Sun. Gravitation tends to crush all solar material towards the center. Thermonuclear fusion, consisting of reactions similar to those in a hydrogen bomb, tends to blow solar material outward. When the processes of gravitation and thermonuclear fusion balance each other, the result is a star of a given size. If the fusion rate increases, the Sun will get hotter and bigger. If the fusion rate decreases, the Sun will get cooler and smaller. When the Sun runs out of fusion fuel, hydrogen, gravitation will dominate and the Sun will start to collapse. For our Sun, this collapse will ignite the nuclear ashes of fusion, helium, and fuse them into carbon. During this fusion process, the Sun will expand to become the type of star known as a red giant. When the helium is all burned, the red giant will collapse. It will no longer give off heat and light. It will then be the type of star called a black dwarf, a cool cinder among billions of others. For a star that's at least 2 to 3 times more massive than our Sun, once the flame of thermonuclear fusion is extinguished, gravitational collapse takes over, and it doesn't stop. The star caves in on itself, and the atoms that compose the star cave in on themselves until there are no empty spaces. The density becomes infinite near these black holes. Even light can't escape a black hole. A black hole is no more massive than the star from which it collapsed. The gravitational field near the black hole may be enormous, but the field beyond the original radius of the star is no different after collapse than before. The amount of mass hasn't changed, so there's no change in the field at any point beyond this distance. The gravitational field around a black hole is usually represented as a warped 2-dimensional surface. Astronauts could enter the fringes of this warp and with a powerful spaceship still escape. After a certain distance, however, and they disappear from the observable universe. Although black holes can't be seen, their effects can be. Many stars in the sky occur as binaries, pairs that orbit around each other. Sometimes only one star of a binary pair is seen. Matter streams from this visible star toward its invisible companion, emitting X-rays as it accelerates toward the black hole. Near the centers of most galaxies are immensely massive, yet very small centers of force that cause stars near them to speed around in tight orbit. These black holes, if that's what they are more massive than 1 million suns.